Good morning, everyone, and welcome to Unit 5, Utility Network of PODS Fundamentals Training. I'm Kathy Mayo. I'm Executive Director of PODS Association. And again, I welcome all of you who are attending. I want to remind you that these sessions are recorded and you can access all of our recordings at your leisure. Today, we have two presenters, and I'm really excited to have Jeff Allen of Esri join us. And we also have Julie Parker, who I think all of you are familiar with, or if you're joining for the first time, Julie Parker is with Teach Me GIS, and she's been PODS trainer throughout this series. So welcome, Julie.
Thanks, Kathy. Happy to be back.
I'd really like to recognize our sponsors for this session. We have our principal sponsor, which is Esri, and our training sponsor, Petro IT. So without our sponsors, this program wouldn't be possible. So again, I'd like to extend my thanks. Julie comes to us from a very rich, deep history or work experience in GIS and in the oil and gas sector. And I think it's been really reflected in the training that she's provided. And so with that, I'm going to just turn it over to you, Julie. And again, welcome,
Thank
Jeff.
you.
And I really appreciate your contribution to this session. It's just key. So
Thanks for having me.
Presenter Julie.
Okay, I'm going to mute my webcam. You guys can still hear me.
There you go.
All right, so let's share. Okay, we should be ready to go. Everything look okay?
Looks
perfect.
Good.
Welcome, everyone. This is the PODS 60-minute session to introduce PODS, those interested in PODS and others that may have already implemented PODS, to terms and concepts that you need to better understand PODS. In this second season of our series, we have been focusing on PODS 7, and we will continue our series on PODS 7 today. So this time we will be focusing on the utility network and its relationship with PODS 7. So if you have not heard of the utility network before, this is going to be a really, really powerful session for you to be exposed to. The intended audience for this series is for GIS or IT professionals, anyone who's new to the pipeline industry with little or no exposure to PODS. And we really expect that attendees will have at least a fundamental understanding of GIS, but just a good interest in PODS or experience with PODS is certainly going to help make some of these concepts maybe click for you too. So before we launch into this particular series, we're going to talk a little bit about recap kind of what we learned last time. In our last session, you gained exposure to PODS 7. We talked about the logical and physical models of PODS 7. You learned how to implement PODS 7 and also extend it for your organization. Lastly, you learned where your data goes and how it gets there during a PODS implementation. So we answered those questions last time. As Kathy said, all of the presentations that we have done in this series, we have one more left in this series that'll be offered in 2 weeks. But all of these are recorded and ready for you to download and listen to again, or if you happen to miss one, you can certainly catch up. So far, this is where we are with our series. You can see our progression so far, and we are here at the Utility Network, which is Unit 5. So you may be trying to understand utility network. Maybe you've heard of it before. Maybe this is all new to you. But basically, I want to introduce utility network to you. I think of it as an advanced tool, really, for managing really complex spatial networks, such as those that we have in oil and gas and water pipelines and utility lines and telecommunication lines and so on. It will soon be integrated with Pod 7. So it's not yet in Pod 7, but it will be soon. And so it's time for you to get some exposure to it so that if you're planning an implementation of Pod 7 or maybe you're transitioning to Pod 7, you can bear in mind that this will be an enhancement to your integration. So let's dig in a little bit and focus on some of the exploratory questions we're going to be asking in this particular series. We'll be looking at trying to find the answers or exploring the answers to what is utility network? How do you know if you need the utility network? How does the utility network connect with Pod 7? And what will you need to create a utility network within Pod 7? Lastly, we'll look at what is the difference between implementing the utility network, or UNet as it's often referred to, with Pod 7, compared with the deployment of the location model components that are found in Pod 7. So our goals for this unit then are to become familiar with how Pod 7 will work with utility network in the future, determine if the utility network is the right solution for you, and understand the proposed connection between Pod 7 and the utility network. You'll become familiar with the requirements that you have are there for creating the utility network. And then also there's a whole set of new terms and concepts and vocabulary that are related to the utility network that you'll be exposed to in this presentation. And just another reminder, UNet is not yet in PODS. It doesn't exist in the PODS Enterprise Geodatabase at this point, but when it is implemented, UNet will provide the connectivity and the rules for the Enterprise Geodatabase. UNet doesn't necessarily have to be implemented with Pod 7. You also have the option of using the existing table structures within Pod and editing them to fit your specific needs. So let's look a little closer at what is a utility network. So the utility network is of course the product of Esri. It's a solution for digitally modeling pipelines. It's a very precise network, very highly realistic network. I've heard it referred to in my research for this series. It's often referred to as a digital twin of the network that it models. It's extremely scalable. It's scalable to implement, but also to expand within your organization and also across platforms. It's accessible because it's web service based, which is a big new thing for many of you, and for those that are new to basing your major applications on services, this will be quite a big deal. So it's accessible because it's providing everything through web-based services, which means that users then, end users, can interact with the utility network on multiple platforms. And so Jeff is going to talk a lot more about this later on in this broadcast today. But I'm just kind of trying to whet your appetite a little bit for you to want to learn more. So continuing on with further defining what is the utility network, it does contain all the features you need to develop or collect a resource for some type, such as gas, water, electricity, telecommunications, and so on. It adds the connectivity that is actually the stuff of a model, right? Everything, all the components are connected together, and it's realistic in the way that it operates because it's rule-based, and it's also all enclosed then within an enterprise geodatabase. So if you already have implemented geodatabase in your organization, then you're going to be well familiar with these concepts. You'll also see that ArcGIS, APR, ArcGIS pipeline referencing, and the utility network are designed to work together within the enterprise geodatabase. So we talk about modeling pipeline networks, and we're excited about the advent and the introduction of the utility network. But it's the latest innovation, and it is quite innovative. You'll see as Jeff talks about it. But modeling networks isn't really something that's brand new. I mean, in the older days, a long time ago when I entered the GIS world, we had nodes and related attribute tables that kind of modeled, loosely termed, modeled the connection between features that you saw on a map and their topological relationships. And then a little bit later on, we've had geometric networks, more recently geometric networks, which store the features, locations, and their connectivity. And that's really the first step forward in allowing us to trace a network. Actually follow the product within a pipeline, or the water through the pipeline, or the current through the line, in ways that we never could before. So that in and of itself was a major step forward. And I think you're going to see, after you see Jeff's presentation, that UNIT is a huge step forward in the way that we are going to be able to visualize and interact with pipeline networks. So today, we're technologically ready to do this type of sophisticated modeling. We have what we need in terms of technology. We are able to use the geospatial tools that we have at our disposal to create very complex pipeline networks, and also interact with them from multiple platforms, whether it be desktop or on a mobile device or on your phone, for example. So it's really exciting to be at this new point in the evolution of modeling, to see what is possible now in the world of modeling pipelines. So before we get too far along, what I'd like to do next is just give a short refresher on linear referencing. Those of you that were in the first season of Pod 7 might remember we did a chapter on linear referencing, and Jeff also joined us for that session too, so I'm glad we could get him back. But I want to refresh your memory because it's been a while since we've talked about linear referencing, and it might help set the stage for where we're headed next later on as we discuss the utility network. So you'll notice the graphic that's on the screen right now. This is an image that was donated by Williams, and you can see just the complexity here of this pipeline. You can see all of the assets and the equipment along the line. You can see a lot of stuff going on this pipeline, and so as you begin to just think about this for a second and think about trying to model it, we know as pipeline professionals that the effective management of pipeline systems is dependent upon really sophisticated data management systems and geospatial models, and like the ones that we've seen on the previous slide. The PODS data model is designed to store, as you remember, and also relate pipelines and all of their associated components. So when you remember looking at our PODS conceptual model, you saw all the various components of pipelines, and you saw the associated tables that help store information about each one of these components and the relationships between them. So when PODS is connected to a geographic information system or a GIS, pipelines can then be viewed and managed spatially and also in multiple dimensions. So most companies consider it a necessity now to view and analyze and manage their assets spatially within the GIS environment. So here's some rationale behind that decision process. The pipelines themselves, for example, have many attributes describing various aspects of the line and its components: MAOP, class, wall thickness, diameter, segment length, vintage, etc. The complexity of pipeline networks, secondly, in the image that you see up above, you'll see what appear to be network components attached to or associated with the line: valves, and meters, and T's, and so on. There's also practical considerations here. It's just not often feasible to go on site to inspect and take measurements or locate components on the line. So all the more reason to have a model or a digital twin, as I've heard, of your pipeline asset system. So let's linger here for just a moment longer, and let's think about why it's important, or it's important, I guess I'll say, to grasp the complexity of modeling pipeline networks in a digital way. And here are a few cases in point. Firstly, every time any one of the attributes associated with a feature changes, there must be a new feature created, but every one of the other values stays the same in a line segment. This management strategy would create lots of attributes in the table. It'd be a cumbersome management scheme needed to capture all these changes. How do you manage reroutes and pipeline segment replacements and reversals and the like? How would you model that in a way that doesn't create a lot of bulk in your database and a lot of confusion in your maps? Another consideration is the regulatory and industry best practice that dictate different rules for managing certain types of pipeline attributes. So for example, if a pipeline manufacturer was unknown and then it was updated to USS, for example, the edit is made without creating a brand new record in the pipeline layer. However, when a diameter changes, the original pipeline record is not updated. Instead, a new record is created in order to maintain the pipeline history. So this is where linear referencing systems come in. This is how we can keep all this stuff straight without having a spaghetti-looking type of model. We have a model that is complex, yet understandable and easy to read. So this is where linear referencing enters the picture here. In this case, the linear referencing system, LRS, is really the ability to locate points by their measured position from the start of a polyline. The ability to locate lines by their measured or by their measurement beginning and ending points from the start of a route. So I've got a graphic up here that might help make this make a little bit more sense to you if you're unfamiliar with this idea. But think about it as a road segment, and try to visualize this measured distance along this segment of road, and you can see that there are features belonging to the road such as the speed limit, changes along the road, the quality of the pavement type, and the number of lanes, etc. You can see there's many different types of information that need to be stored about this road, but it doesn't necessarily all have to be stored on separate physical lines associated with the road. In linear referencing, we can store all this without stacking up lines of polylines along this road network, because the linear referencing system is smart enough to calculate locations of each one of these attributes of the road without having to create new roads or new road segments themselves. So you're not ever really creating the scenario that you see on this next slide where you've got separate and distinct lines. All this is measured and calculated. The locations of calibration points and T's and meters and valves and so on are not stored in individual center lines. Everything is associated with one center line. And it's the linear referencing system that allows these segments to exist on the same center line using measured values. So to bring this back to Pod 7, we've looked at the conceptual model, which you can see on the left-hand side of your screen there. And you'll notice that I've marked it up a little bit. I've got some of this darkened back, so I really want to focus your attention on the linear referencing system. As it has existed, the linear referencing system has existed in previous versions, it's still a part of the conceptual model. The difference here at Pod 7 is that Pod 7 has adopted the APR, the Esri APR linear referencing system as one of the core tables for managing these linearly referenced networks that we saw just a second ago. So pods, it doesn't mean that Pod 7 will only work with APR, Esri APR. It just means that PODS Association members can use APR to manage information within the PODS Esri database, geodatabase. It also works with several other data models, I guess, as you'll see. So lastly, I just wanted to show you a little bit about what the geodatabase might look like in an implementation. So you would add the featured data set into your ARC catalog, for example, to view what it looks like once you've activated it, and you'll see that it's a featured data set loaded. In the graphic there showing it in ARC, but you'll be accessing this through ArcGIS Pro when it becomes available. But you'll notice that it stores the features in the data set. It also has all of the lookup values being handled by the Esri geodatabase domains, just like you're probably already used to for many of the other elements of your geospatial databases. So because APR is in Pod 7 and at work at Pod 7, APR, the APR is actually assuming the relationships and is handling them kind of in the background for you. So there's a lot more to unpack here with APR, with linear referencing, and with the utility network. And so I want to welcome Jeff back to this series and invite him to take the screen now and continue on with describing more about the utility network.
Cool, thanks, Julie. So thanks everybody. Thanks for joining today. I'm going to dive into a little more details on the utility network pods implementation pattern, right? So when we talk about that implementation pattern, what we're really doing is really talking about the changes we need to make to the core model to allow the Esri utility network to work against the pods out of the box model. This is very similar to what we did when we implemented the core tables for the ArcGIS pipeline referencing. And when we think about some of those key questions that Julie posed in the front of the slides, one of those is that I get commonly asked is, why do I need utility network? Why do I need anything more than linear referencing? And the utility network really brings to the table this idea of connectivity and be able to go deeper into the modeling of the pipeline assets. And this is really key as the GIS in most organizations, it started as really desktop tools, became a departmental system. Most of the GIS systems within these pipeline companies are now really truly enterprise systems, right? This is the single version of the truth of all the assets. And to be able to have all those assets mapped and be able to interface with other systems like SCADA and maybe SAP or Maximo or other work order management systems, we have to have a higher fidelity of data in the data model. And oftentimes that higher fidelity of data and be able to understand how assets are connected together is challenging when we only have linear referencing tools to work with. And that's really where the utility network comes into play. And so when we looked at the whole supply chain, from meter tip to wellhead and all pipes in between, we kind of see the industry broken down into, or we view the industry kind of broken down into these three major segments. We had the upstream, which we would consider the gathering pipes, both onshore and offshore. The midstream, which is the larger diameter transmission system where we've typically deployed pod solutions, and then the downstream, whether that be on the natural gas side, the distribution networks, or on the hazardous liquid side, inside the fence, the refinery and trucking terminals and things like that. And so when we look at where we've traditionally used linear referencing, it's been on these hazardous liquids and gas transmission systems. But where we see the real need for connectivity and where we have limitations in that linear referencing systems are in these upstream gathering lines. Obviously, downstream distribution has been traditionally a network, and even what we call kind of inside the fence piping. As we get into more details of these facilities along the pipeline, when we need to model what's inside of there, be able to go inside the fence with linear referencing has traditionally been a challenge for us. And that's really one of the key benefits of the utility network is we build that connected layer of pipes, and where we need it, we can drop linear referencing on top of it. So we get kind of the best of those both of those modeling techniques. We get a connected network and we get the ability to use linear referencing together in one single enterprise geodatabase. And so to do that, we have that PODS database, the PODS 7 data model sitting here. And to manage both a connected network and a linear referencing network together, what we would do is then we would use two Esri tools on top of that, one being pipeline referencing to manage the linear referencing piece, and the other to be utility network to manage the connectivity of those pipes. And that would be able to give me that entire connected supply chain inside the single enterprise geodatabase. And again, when we talk to customers, this is one of their single key drivers is they want to eliminate a lot of this redundant data they have in multiple databases, whether it be in a legacy relational database, having to replicate that data to a spatial data model to then share it with the rest of the organization on web maps. They want to simplify these systems work, but they become too complicated. And this allows us to have a single enterprise geodatabase and simple tools that edit that data directly out of the box. So when we layer in that utility network in combination with linear referencing, Julie mentioned a lot of the key benefits of the linear referencing components. Here's what we sort of add to the mix from the utility network. Obviously, the mapping component is huge for us, being a mapping company, but also alternative ways to view those maps. So we can take that same data that we've put into utility network on the geographic map and create operational diagrams and schematics from that data. As we start to layer in more and more details onto the map, then we also have to think about how we organize that data. We can't just show all this detail in mass on a single map, and it would be too confusing. So we've come up with this concept in utility network called containers or component views, which is basically a GIS within a GIS. So I can set up a container and inside of that container, whether it be a point or a polygon, then further describe all the elements that make that up and be able to stack those objects together and really kind of create a hierarchy of the objects in the geodatabase. Then once we have the data mapped, obviously the advanced analytics, the one that mostly would come to mind would be the tracing algorithms. The tool also supports both historical and plan views. So I can see what's happened in the past with my facilities, go back in time and history, as well as start loading in proposed pipe and seeing the impacts to the network from those proposed pipes without necessarily exposing those proposed or projects to the rest of the operations until they are flowing product. And then the last one we're getting a lot more demand for these days is to be able to not only map in 2D, but truly map in 3D as well. So especially when we get into these confined spaces in these facilities, be able to map all these vertical pipes correctly within the GIS is a huge requirement. So you implement a utility network, picks up these sort of core capabilities. I talked about tracing because this is obviously a big part of that connected network, right? So once I know how my pipes are connected together, not just at the route and series level, but across the entire network, I can start doing some interesting analysis. Like I can start look at isolation zones. You know, what devices along this pipeline actually control the flow? And if I turn this this valve off, how is the network impacted? Pressure zones is another big use case inside of the utility network as well. So I can now define devices that either step up or step down pressure, and then look at all the components downstream that might see that same pressure either increase or reduction. Think of this as my system MAOP, for example. And then that cathodic protection as well. So not only what I'm modeling for the flow of the product, but I can also model other things like what devices are electrically connected together that make up my CP system. So as much as the valve might isolate my pressure zones, an insulating flange, for example, might isolate my cathodic protection zones. And I can now model those devices correctly in conjunction with the pipes and look at those systems that might be needed for my CP group. And I can sort of look at those devices. Devices now have intelligence beyond just a point on the map. So when I describe devices that control pressure, I can start asking the system some interesting things. For example, I can say, look at all the devices downstream of, say, this regulator, and tell me what the lowest MAOP design is for any component you find within that network. This is something that we've been able to do in linear referencing, but really in a more brute force way. You know, we've had to describe what routes or what lines connect together and what, how things branch connect and build a pseudo connectivity model in the linear referencing system. More importantly, although you can do it, you still have to maintain that data as well. Here, what happens in the utility network, as soon as I add a new pressure regulatory device and describe it, all the pipes and all the fittings downstream of that device are automatically connected to it and discoverable through a trace. So it makes the maintenance a lot easier, and it opens up the analytics of what we can do in the system, and it makes the system more stable from a system of record perspective, because it really truly is representing the physical objects that are in the field, representing those objects in the geodatabase. And then finally, another kind of real key point to the utility network is business rules. So we've introduced the concept of a business rule or a rule base to the utility network, but not only added that rule base, but made that rule base at the server level. So we've had rules and we've had rules around pods forever, but most of those rules have resided at the client level, right? So if we've had rules about editing, they sit on the desktop, and if we want those same rules to apply to editing on a mobile application, we've had to replicate all that code onto the mobile app. Now with those rules really sitting at the server level, regardless of what platform, whether you're a developer or a mobile application or editing from a web viewer or editing for a desktop tool, all that data has to pass through that business rule base before it gets applied to the underlying geodatabase. And this is key because, you know, we've seen this in the past where, let's take, for example, somebody's built a geometric network and then somebody else opens up that geometric network and breaks it because they don't understand how it's built and how it's maintained. Here, that's not possible. To be able to edit the utility network, you have to pass those edits through the underlying rule base. You cannot sneak around the rule base and make an edit behind the scenes that might break the connectivity or might break the associations that we've built up. So makes the data much more consistent, protects your data in that geodatabase, and allows you to apply these rules consistently across the organization, regardless of where those edits are coming from. So if we think back about how we implemented support for Esri's linear referencing into the pod model, we stepped back and we look at the core linear referencing, what we call information model, right? I'm very cautious never to call it a pipeline data model because it's not. These were just the core features and core tables that we needed to implement to allow the Esri linear referencing tools to work against pods. And so if you were to look at pods today, you'll find those key fields and you'll find those key relationships inside the pods data model. Now, of course, pods has literally thousands of other attributes and hundreds of other tables that surround this, but this is really the sort of data model agnostic pieces that we need to implement into pods to make the Esri linear referencing work. And so that's what we're doing for the utility network implementation as well. We basically look at the core information model for the utility network and then figure out how we can take this core information model and place it into the pods database. And so here's what the utility network really needs at its core. It's broken up into different domains. So you can have in the same geodatabase a gas domain, electric domain, a fiber domain, and a water domain all working together. And so we've had customers come to us with use cases saying, hey, not only do I have my hazardous liquids and gas pipelines, but inside this facility, I've got a water suppression system, and I want to be able to add that and have its own connectivity, or a steam injection system. Or I have another customer that actually is building out a fiber network in West Texas, and they want to maintain their fiber lines. Or in a gathering field, they're actually responsible for maintaining the electric system, and they want to know how that is in the GIS. So we can add in all these additional domains into the geodatabase, but really what we're fitting into pods is the core, what we call gas and pipeline domain. And that's made up of 5 key fields, 5 key feature classes. So everything has kind of been boiled down from a performance perspective into these key feature classes, and heavily relies on subtyping to then split out the individual objects that you would place in the utility network. So you have devices that control the flow. You obviously have the pipelines themselves. You have junctions that describe connectivity. You have assemblies that describe those higher level container objects. And we have a 5th feature class called the subnetwork that really is maintained by the system that gives you a summary of all those pipes that are connected together, either in a pressure system or an isolation zone or a CP system. So this is your hierarchy of the utility network that's maintained by the software behind the scenes. And then you can see up above, there's a rule base that also gets implemented in the utility network as well. Now, the way that we deliver a utility network is something called an asset package. And an asset package is simply a file geodatabase with all the rules and all the definitions inside of it exposed as tables. So it's a portable way for us to move utility network objects around from enterprise geodatabase from enterprise geodatabase. So we will be delivering pods, a version of pod 7 as an asset package that you can then load into a utility network enterprise geodatabase. It would load all the connectivity rules, all the subclass domains, and all the rule base, and allow you to edit those with the ArcGIS Pro utility network interface. So the idea here is to add yet another domain, right? So like I said, you can have multiple domains in the same enterprise geodatabase. There is a third domain or a fourth domain here called the structure network. These are things that are connected to the network, but not necessarily contain or flow product. So a structure might be a pipeline hanger or an assembly, or I'm sorry, a casing, or something else that's connected to the pipeline that's just sort of a structure associated with it. Those are contained within their own set of tables as well, and I'll show you some examples of those. But we'll build out this pods network domain and allow you to add that or upload that into the enterprise geodatabase through an asset package. And so the working group that has been working on this project, really what we needed to do at a very simple high level is to be able to get this pods utility network compatible domain network built, is go back into the pods 7.0 model and identify which features would participate in the network. So we're not bringing everything from pods into utility network. We're just bringing the pipes and the fittings and the junctions that control the connectivity and flow. We're identifying those objects, and then we're mapping those into these kind of key feature classes in the utility network so that functionality works. And so let me show you where we kind of are with that process. I'm just going to switch over to an Excel worksheet here. So what this Excel worksheet shows you is sort of all the features that we've currently have inside of the pod 7 database. So these are all the individual tables or feature classes, depending on your implementation pattern, that you'll find in pod 7. And you'll see here we've got this centerline feature class, and I've kind of got it in red and lined out. When we integrate the linear referencing system and the utility network, what happens is that generic centerline that we've used for linear referencing gets replaced with the pipeline itself, the pipe features of the utility network. So centerline goes away. The pipe in my utility network becomes the basis for my linear referencing system. And then I would add all my linear referencing objects on top. So the first key kind of sorting that we did was identified which features would continue to exist in linear referencing, and those are indicated with dots here. And then those features that we would move over to the utility network. And then what is that core feature class that object would fall into? So if we think of this, and let's look at a couple of these, if we think of a branch connect, right? It's going to become a utility network object. It's going to go into the junction feature class, and then the asset, what we call the asset group inside of there, is going to be branch connect. So we're pulling over that naming convention from the pod 7 feature, and instead of creating a feature class for that, we're creating basically a coded domain inside the junction feature, inside the junction feature class for that type. You can see other ones here. We've got closures, elbows. Here's an assembly. So the launcher receiver, obviously a launcher receiver is made up of a whole bunch of components. It's got pipe and elbows and T's and reducers and closures. So in the utility network model, we'll create the launcher receiver as an assembly, which would be basically a collection of those objects and then be able to further describe all the individual components that sit inside of that assembly. Then you can see other things like, let's find a device here. Okay, here's the valve, so that'll go into the device. Now, interestingly enough, beyond just a point in the geodatabase, some objects also have what we call terminal configurations, which mean that the device actually is configured on how it connects to the pipes on either side of that device. So a meter would be a device, and it might have an inlet and an outlet port of that particular meter, or a valve, which could be multi-flow, but it could go flow both directions. Its configuration would just be port 1 and port 2 because we can equally connect it to the pipes on our side. Or something like a pump or a compressor, it would have a low pressure side and a high pressure side. So you see, as we place these point events or these devices along the line, and we define the connectivity of that device to the pipes on either side, that's how we start building out that hierarchy. That's how we start to build out those pressure systems and isolation systems based on that configuration. And once I have that sort of wired in, then I pick up all that functionality. Now, once we've done this high level mapping, you'll notice I have a couple things here in green where I have dots on both sides. And that's because as a group, we've decided that these are really kind of an operator implementation pattern decision, right? A girth weld, we could easily create a junction in the utility network for a girth weld. But if you think about how many girth welds are in there, do you really want to burden your network with that many individual segments if it's not really necessary? So one of our thinking is that girth welds, for all intents and purposes, could stay as a linear referencing object, or they could be put in as a junction on the utility network. Same things with things like pipe length and operating condition. You know, do these stay linear referencing events, or maybe they just become attributes of the pipe? So there's a couple of decision points as you implement the model that you'll be able to decide based on what's going to be delivered from pods itself. But ultimately, then once we understood which objects fell into the utility network, then we really needed to dig into the details of what each of these utility network feature classes required. Because utility network is, because it's rule-based, we have to build rules around attributes, and attributes require data, not just that it's a branch connect, but what type of branch connect, or what type of fitting, or what type of valve. So we've now further started to break down, for example, here's the pipeline lines feature class. And you can see we've got groups of pipes. We've got gathering, transmission, distribution, station, cathodic protection. We've got that, and then we just started to define those asset types. So this is the next level of attribution, and we've been pulling those from the standard pods domain tables that exist in Pod 7 today. But as we went through here, we started to find things that, as you really dig into these domain codes that we've never done before, we start to see things like, hey, does the girth weld really, is plastic valid, or this should really be a pipe type? And we found some other domain values in here that really needed to go into different places within the model. So that's where we started to really break out and start defining now code lists, our standard delivery of code lists of major items like meters and valve types, compressor types, traps. And you can see we still got some work to do here around things like T's. Here's what we've identified for the major assemblies. So compressor assemblies, meter assemblies, big trap. These are objects that contain other objects inside of them. That's why they have an association with a container. And here's an example of those sort of structure boundaries, things that don't actually contain product, but that might be along the pipeline. So structure boundaries and structure junctions as well. We've started to find from what's inside of the utility network. So let me show you really quickly what that looks like in a real practical sense. So I'll switch once again. to my remote desktop window here. And so here I have just an example of both a linear referencing system and a utility network system working together. And in this example, I've got a couple of key areas that show that functionality, right? So here in the gathering system, where I have more of a network of connected pipes, and it's really difficult for me to, maybe create routes or measures where they don't exist, or try to maintain a linear referencing system here. Basically what I've done is just added all these pipes into the utility network and then created the connectivity model within inside the station. And then as I come back down, say into this facility here, be able to then jump on top of those pipes and start defining my linear referencing system. But here, if I go to my utility network and turn on my associations, you can see I've got a connectivity model behind the scenes here that allows me to dictate, hey, the end of these lines here, and what I've got to define that connectivity is a bunch of junctions at the end of these gathering lines do in fact connect through this facility into these meters and into these compressors at the beginning of this transmission system. And then I start my linear referencing system going downstream. And this allows me to do some interesting stuff. If I just move down here a little further along the way, as I enter into the next station downstream, you can see I again have some stationed pipe here. And then I have a launcher receiver assembly that I might not have stationing for. And if I turn my base map over to imagery, I've got some more kind of complicated stuff. I've actually got a compressor station or a pump over here in this building. And again, I can create these objects where they exist, and then using the utility network connectivity, define my linear referencing here to the mainline valve, has some non-stationed pipe inside that launcher receiver assembly, and then create a connectivity association between the end of that pipeline there over here to this pump or compressor and back out the other side. So now I've got linear referencing and fully connected model in and out the other side. Or maybe I know some more stuff in here, but I don't know where it is spatially. So I can start to lay out more of a kind of schematic view of those facilities as well. So if I zoom on down here in the line, typical example where I have sort of three transmission lines coming together, it's not really clear how this, unless I zoom out, or maybe if I look at the stationing, how all these things are connected together. And here what I've done is created what I call a container, which is this point object here that contains the facilities inside of that facility. And if I click on that assembly and open up that container and go on inside, what it'll do is open up the model and show me what I have for objects within inside of that container. And there's all my devices. Just zoom over a little bit here. There's all devices. So I've got some meters, some flanges, looks like some pumps or compressors here. And again, all connected back to those transmission lines. So I can see exactly how, okay, it looks like I come in off of the main line here. I go through some type of T into two valves, into those meters, and then out into the compressors or pumps out the other side, and then back onto the linear referencing network. So again, just because we say we can map all this stuff inside this facility doesn't mean we have to have it all sort of geometrically laid out. This can be an inventory of things and a connectivity of things inside this station of the major components that are now discoverable as I do a trace on down this line, right? And so we can start at this level, but really what customers are looking for is for us to now go and start really mapping out what's inside of these facilities. And if I just zoom up down the line here, give this a second to exit the container. where we're heading with all this is really getting down into the details of being able to find, all the pipes, not only along the transmission line, but inside the fence as well, right? So here I've got the main run coming into the station. You can see my linear referencing system in red there with my engineering stationing on my launcher receiver. I come off my launcher receiver into this facility, into this building here, which has some more components connected out the other side, across the station, and then out the other side into my utility network again. So this object here, these blue lines, are the utility network pipes. So these pipes inside the fence here are non-stationed. Obviously these red pipes have stationing on them, but the reason I've been able to do that is because I've defined a route and measure on top of the pipe. So if I just turn off my linear referencing network for a second, you can see those blue pipes extend all the way through on either side of that that station there. So the pipe is drawn first into the utility network, and then I define the linear referencing on top of that. And it's very easy to do. All I have to do is put my pipes into my linear referencing system, put my pipes into my utility network, create begin and measure on those pipes, because those are going to be the measures that my linear referencing system is going to start with. So in this case, if I just select this piece of pipe here, look at the attributes of that pipe, I've already defined on this pipe segment the from and to engineering measure for this piece of pipe. So I go from 0 to 80 here. If I select on this pipe here, I go from 80 to 92 plus 00. So I define my pipe, all its characteristics. I add the begin end measures to the pipes themselves, and then to go ahead and now create linear referencing on top of these utility network pipes, I just use the same way I've been doing it all along, except instead of using the center line, I'm going to use those pipes themselves. So let me select on this pipe, hold down the shift key, select on that pipe. So I've got two center lines connected, the two pipes from my utility network. I open that up, I select what linear referencing system I want to add them to, my start date, I'll give it a route and a line name. You can see it's automatically picked up the from and to measure from the underlying pipes underneath. And now when I run that, and let me just clear the selection. Now I've got a linear referencing system on top of that connected network. If I did a network trace now, I would discover all these pipes, and then I'd pop back out to my linear referencing system on the other side. So that's where we're heading. You'll be able to do all this with a sort of out of the box PODS model. It'll come delivered with obviously the location referencing configuration already built into it that we're adopting from POD 7, and then rearranging those tables and feature classes to allow it to have all the functionality of the utility network. And then going forward, you'll be able to map in a single geodatabase both stationed and non-stationed pipe, and then be able to share all this out with the organization. The real key here is that all these objects that you're seeing on the screen are simple point and lines. So if I want to take this now, share it to a web map or share it to a mobile device, I'll be ready to go. And with that, Kathy, I'll turn it back over to you or any closing comments. Kathy, you're on mute.
Thank you, Jeff. What I sense when I see this is it's truly the missing link in the work that Esri has done on utility network and pioneered it with an operator early on, and now working with the committee within PODS and ONEOK to further develop it out is just tremendously exciting. So the granularity and the richness in data and information is really commendable and quite exciting. So thank you for that. Thank you very much, Jeff. And with that, let me turn something on if I can. Show my screen. I'd like to again thank our sponsors, Esri and Petro IT, for supporting our training program. This again is Unit 5. It's been recorded. You can go to POD's website to access it. Our last unit is Unit 6. That's our final training in this POD's Fundamentals. Will be December 15th. So go over to that and register if you haven't already. And with that, I would like to extend my thanks to Julie and to Jeff for their presentation today. And with that, we'll be signing off. Thank you very much.
Thanks, everybody.
Thanks, everyone.